Welcome back. We're going to continue our discussion on a brand new topic, and that would be aldehydes and ketones. Now, of course, you would need to know knowledge from your previous material to be successful in understanding the content as part of this series. But there's also some new things that we will learn as we go along, right? Now, if you remember, we did spend a considerable amount of time on functional groups, right? And using them to name a compound based on a priority of functional groups, right? And there we have learned about aldehydes and ketones, right? Now, what is the functional group for aldehydes? Okay, if you remember, the general formula I wrote is R, C, double bond O, and H, right? Now, this H is not an option, okay? This H is what makes it a aldehyde, right? Now, if I get a different color, I can re-emphasize it, okay? This is not an option, okay? This is what makes it an aldehyde, okay? Which means you cannot ever have an aldehyde where the C double bond OH is inside a chain. It always is at the very end of a chain, okay? Now, if you also remember when I mentioned the functional group for an aldehyde, this is the functional group itself, but what is R depends on the length of the chain, right? Now, for an aldehyde, R can be an hydrogen, or it can be CH3, or CH3, CH2. Now, if you notice in all the cases, I'm one hydrogen short, right? Because you cannot have CH4 here because then that would make it 5 bonds. So it has to be CH3. Now, CH4 is methane, so this would be methyl, right? Now, all this is foundational. This is not something you have to act like you know it. You never know it. This is all is being taught to you. And now this would be ethyl, right? And then you can go on with the list. But there's a foundational difference between aldehyde and ketones, which we'll see in the next video. Is R can be hydrogen for an aldehyde, but if you want it to be a ketone, then we will also see that you will not have a hydrogen to start with, nor your hydrogen R cannot be hydrogen, okay? But we'll worry about that when we get there. But I just want to point that out so you see the foundational difference between an aldehyde and a ketone, right? Now let's see if you can remember how you name them. Well, as I said, if your molecule is an aldehyde, then you would see that this group is at the very end. Okay, now this is a carbon right here. Okay, let me go back and delete that so I have a clean chain. Now I'm going to get my red color back. Now, naming aldehyde is probably the easiest. You start with the carbon containing the functional group, which is this. So that's 1, 2, 3, and 4. So we have 4 carbon, right? And 4 carbon is butane, right? And as I said, all you got to do is really get rid of the E and put an Al for aldehyde, okay? So it'll be butanal. That's all. Replace the E with an Al. Now, what if you have substituents? Then you have to still figure out your longest chain, which is this, right? This is your longest chain. Now, let me get a different color so I can highlight this to you. So you have, again, you start numbering from the side, or start counting from the side containing the functional group. So this is 1, 2, 3, 4, and 5. Not only you should have a long chain, but the long chain should also contains the functional group. Again, this is information we have learned in Chem 330, but came back to it again in 335. So you should know that. That means this will make your substituents. So you start numbering from here. So 1, 2, 3, 4, and 5. So with aldehydes, naming is very easy. Like I said, 5 carbon is pentane, right? So the last name is very easy, pentanal. Now don't do this for Don't do this if your molecule contains a double bond. Okay, there's got to be some differences that has to be made, but we'll worry about that when we get there. So this is pentanal, and then you have a methyl group in 2 and 3, so 2,3 dimethyl pentanal. Okay. Now, just for a kick, let me just say, what if your compound contains like this? Contains a double bond. Okay, you have, as I said, you have to make that difference, right? You don't make the you don't do too many changes in terms of your knowledge restructuring. All you got to do is the same. So 1, 2, 3, 4, right? So that's 4 carbon, right? So that's butane. So if that double bond had not been there, then it would have been just like the one above. It's butanal, right? But we have a double bond, right? Now, where do we start numbering from? The side containing the functional group, because aldehyde has a higher priority over a double bond. So it's 1, 2, 3, 4. So the double bond is between 2 and 3, right? So how do we write it? It's basically the double bond is between 2 and 3, right? So you say but, right? Butanal, which is but, it's between 2 and 3. So but 2 ene, right? And then this is Al, right? If you go back to the priority chart I gave you, aldehyde is Al, as it's obvious. So it's in one spot, so 1Al, right? But 2-ene, 1Al. So the double bond is always a troublesome one. If it's not the double bond, things are much easier. Only CC, we did this very easy, butanal. We had no problems with this. As soon as we got here, even I had to think for a second, because I don't want to write something wrong here that you would have to remember, and I'm very cautious of that. So it's between 2 and 3, we have 4 carbons, so it's but 2-ene, because that's what a double bond is for, hyphen 1 is where the aldehyde group is, so Al, right? As I said, there's no other way an aldehyde could be inside the ring, because that's what makes it an aldehyde in the first place. All right? Now, there's only one synthesis method I want you to remember, and I don't want to get into mechanism for this because there's hardly a whole bunch of information you would have to know, so I want to keep this simple. The one thing is, if you want an aldehyde as your product, then you must start with the primary alcohol. Okay? Secondary alcohol will give you ketone. Primary alcohol as your reactant will always give you your aldehyde. Now, what does this PCC and PDC stands for? PCC stands for pyridinium chlorochromate. Pyridinium, you don't need to remember this, but good to know the information. Pyridinium chlorochromate. It's an oxidizing agent, okay? This type of reaction, whenever you use the PCC or PDC, or you go from an alcohol to an aldehyde or alcohol to a ketone, it's part of a larger classification, which we will come back to again and again. It's called oxidation, okay? Pyridinium chlorochromate is PCC, and PDC is pyridinium dichromate. Okay, these are excellent oxidizing agents. Pyridinium dichromate. Okay. Now the point here is that this is an oxidizing agent. The cool thing with alcohol and ketones when you're oxidizing them is you get to keep the same number of carbons. So here, this is a primary alcohol. So we have 1, 2, 3, and 4, right? So your aldehyde should also contain 4 carbons. So 1, 2, 3, 4. Well, if you don't put the double bond here, okay, and the oxygen and the hydrogen here, this is 1, 2, 3, 4. Okay. Basically, you want to stop at the top and then add your double bond O and H. So this is your aldehyde. Okay. Now, if you had started with 3 carbons, then you end with a 3-carbon aldehyde, which this is nothing but same as the one I drew here. And this was done on purpose so that you know what the name of it is. It's butanal, right? So primary alcohols, let me write this in a different color. So this is the take-home message from this. Primary alcohol, okay, which is a carbon containing the OH and 2 hydrogens, when oxidized, this is a summary of what I just said above, will produce aldehyde. So primary alcohols, when oxidized, will produce aldehyde. Now, these are some of the oxidizing agents that are available, which is PCC or PDC. You don't use both. You use only one of the two. So when you oxidize a primary alcohol, you get an aldehyde. Okay, and this is butanal. That's the name of the product. Because I explained it earlier how we got it to be butanal in the first place. But the point here is, this is not a carbon. This is where the carbon stops. So you put the aldehyde group on the very last carbon. So you don't draw extra and add one more. That will make it 5 carbon. So that's why I always recommend you put your dots to count and then come back and put the dots again. So 1, 2, 3, and 4. There we go. So this is a brief introduction to aldehyde. And then we're going to do the same with ketone, and then we're going to combinely learn a few reactions for aldehyde and ketone. Right? This is all you need to know for aldehyde. So I don't want to bring too many synthesis methods. Now, I do want to bring out something. Here we are oxidizing a primary alcohol, right? The reason we're using a pyridinium chlorochromate or pyridinium dichromate is because these are large oxidizing agents, which prevents the alcohol, which prevents the aldehyde getting further oxidized to an acid, which we will see down the road. Okay, if you had used any other oxidizing agent, you would have gone from an alcohol to an aldehyde to an acid. But the PCC or PDC restricts just it to an aldehyde. All right, so stay tuned.